رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي.
Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope all of you are fine and doing well. स्टार्ट करते हैं आज की अच्छी बात से। और आज मैं आपके साथ कुरान पाक की सूरह ताहा की एक आयत शेयर करना चाहती हूँ जिसका तर्जुमा कुछ इस तरह से है, और जो मेरे जिक्र से मुंह मोड़ेगा तो मैं उसकी ज़िंदगी से सुकून छीन लूँगा। डियर स्टूडेंट्स, हमें कोशिश करनी चाहिए कि हम अपनी ज़िंदगी में अल्लाह पाक का जिक्र करने का मामूल बना लें। फिर चाहे वो जिक्र इस्तिग़फ़ार की सूरत में हो, या किसी भी किस्म की दुआ की सूरत में हो, या किसी भी किस्म के वो कलमात हो, लेकिन हमें जिक्र करते रहना चाहिए। आज के लिए जो हदीस मैं आपके साथ शेयर करना चाहती हूँ वो कुछ इस तरह से है। रसूलुल्लाह सल्लल्लाहु अलैहि वसल्लम ने फरमाया, दो कलमे ज़ुबान पर हल्के फुल्के हैं लेकिन मीज़ान में इंतहाई वज़नी और अल्लाह ताला को अज़ हद महबूब हैं, और वो कलमात ये हैं, सुबहान अल्लाह व बिहम्दिही सुबहान अल्लाहिल अज़ीम। पाक है अल्लाह अपनी खूबियों समेत, पाक है अल्लाह बहुत अज़मत वाला। तो डियर स्टूडेंट्स, ये तो एक जिक्र या तस्बीह या कलमा हम कह सकते हैं जो कि बहुत ही छोटा सा है, लेकिन जो इसका अजर है वो इतना ज़्यादा है कि वो मीज़ान को जो है वो बहुत ज़्यादा वज़नी कर देता है। तो हमें अपनी ज़िंदगी में इस तरह के कलमात को शामिल करना चाहिए ताकि हम ज़्यादा से ज़्यादा जो है वो ज़िक्र कर सकें और अपनी आखिरत को हम संवार सकें, अपने नेक अमाल को हम बढ़ा सकें। Dear students, now let us start the lecture number 5 of unit number 1, which is measurement. And in the today's lecture, the learning outcomes will be the dimensions of physical quantities, the advantages and the limitations of the dimensional analysis. आज के लेक्चर में हम लोग डायमेंशंस के बारे में स्टडी करेंगे कि डायमेंशंस होती क्या है और उनके एडवांटेजेस क्या हैं, उनको हम किस तरह से यूज़ कर सकते हैं और उनकी लिमिटेशंस क्या हैं। क्योंकि जब भी किसी चीज़ का फ़ायदा हो रहा होता है तो उसके साथ साथ उसकी कुछ ना कुछ लिमिटेशंस भी होती हैं जिससे बियॉन्ड हम उस चीज़ को यूटिलाइज नहीं कर सकते। So first of all, the dimensions describe the physical nature of the quantity. क्वांटिटी हमारे पास फिजिकल क्वांटिटी जो कि मेजरेबल क्वांटिटी होती है। सो फॉर ईच बेसिक मेजरेबल फिजिकल क्वांटिटी it is represented by the specific symbol and which is written within the square brackets, and that is known as the dimension of physical quantity. एक particular symbol जो कि assign किया जाता है to the physical quantity, to the basic measurable physical quantity, which means to the base quantities, the dimensions, their symbols has been specified. और dimensions को लिखने का method क्या है? dimensions के जो letters होते हैं उनको हमेशा square bracket में लिखा जाता है। And now there are some of the basic dimensions which are associated with the base quantities. Since there are 7 base quantities, so there are also 7 dimensions associated with these 7 base quantities. For length, the symbol of the dimension is capital L, which is written in the square bracket. For the mass, it is capital M. For time, it is capital T. For electric current, it is capital I. For temperature, it is theta. For the luminous intensity, it is capital J. For the amount of substance, it is capital N. By the convention, physical quantities are organized in a system of dimensions, and each of the 7 base quantities used in the SI is regarded as having its own dimension, which is symbolically represented with the single Roman capital letter. And while the all the other quantities which are the derived quantity, they may be written in terms of these 7 base quantities by the help of the equations of physics. The dimensions of the physical quantity actually does not depend on the magnitude of the quantity. For example, the radius of a circle, the diameter of a circle, the chord, or the circumference of the circle. Physically, all these 4 terms are different, but dimensionally, all of them are equal because the radius is actually a length, diameter is also a length, chord is also the measure of the length, even the circumference of the circle is a measure of length. So physically, all of them has the different meanings, but dimensionally, all these quantities are similar. So इन सब की जो dimensions हैं वो length की ही dimensions होंगी और इनके जो units जो कि हम इनको measure करते हैं ऐसा unit जो इनके लिए use किया जाता है वो भी meter है. लेकिन quantity wise ये सब different quantities हैं. Circumference of the circle different होता है as compared to the radius, diameter is different as compared to the radius, while radius is different as compared to the chord. So all these 4 quantities are different, but dimensionally all of them are similar. So ये मैग्नीट्यूड पे डिपेंड नहीं करती, डायमेंशंस डिपेंड करती हैं उन फिजिकल क्वांटिटीज की नेचर पे. इसी तरह से अगर हम वेलोसिटी वर्सेस टाइम ग्राफ को देखें तो इसमें हमारे पास वेलोसिटी की कोई इनिशियल वैल्यू है, फिर वेलोसिटी इंक्रीज कर रही है, वेलोसिटी डिक्रीज कर रही है, कुछ पॉइंट के लिए इसमें कांस्टेंट वेलोसिटी है. सो if there is a change in velocity, the initial velocity, the average velocity, the final velocity, for the speed, all of these physical quantities are different from each other, but the dimensions for all of them will be similar because all of them depends on the length and the time. So dimensions इन सब की सेम हैं even though कि ये क्वांटिटी जो है वो एक दूसरे से मुख्तलिफ होती हैं. So जो dimensions है हमारे पास फिजिकल क्वांटिटीज की वो मैग्नीट्यूड पे डिपेंड नहीं करती और मैग्नीट्यूड को कंसिडर भी नहीं किया जाता in the dimensional analysis. And some important derived dimensions in terms of the base dimensions are, for the velocity, it depends on the length per unit time, so Lt minus 1. For acceleration, its dimensions depend on the length per unit time square, so Lt minus 2. Force is mLt minus 2 and so on. Length area depends on the square of the length while volume depends on the cube of the length, and similarly with the help of the physical formulas of these derived quantities we can be able to write down their dimensions. And usually हम जो ज़्यादातर physical quantities को जो use करते हैं उनकी dimensions 3 ही dimension पे जो है वो depend कर रही होती हैं, length, time और mass पे. So the dimensions of any derived quantity is written as the product of the powers of the dimensions of the base quantity. Generally, हम किसी भी quantity की जो dimension है उसको base quantity की powers की form में लिख सकते हैं, क्योंकि ये ज़रूरी नहीं है कि हमेशा dimension की power 1 हो. It could be negative, it could be positive, it could be greater than 1. So just like L to the power alpha, M to the power beta, T to the power gamma, I to the power delta, and so on, where the exponents alpha, beta, gamma, which are also called the dimensional exponents because these exponents are associated with the dimensions of the physical quantities. And now we will study about the some terms which are used with the dimensions. First of all, the term which is used with the dimensions is the dimensional variables. Variables means ऐसी quantity जो कि change होती रहती हैं, जिनका magnitude constant नहीं होता. So the physical quantities which have the dimensions of variable magnitude are called the dimensional variables. For example, force is not constant. It could vary energy, acceleration, speed, velocity. So all those terms which have the variable magnitude, all those physical quantities which have the variable magnitudes are called the dimensional variables. Second term is the dimensional constants. ऐसी values जिनके magnitude constant हो लेकिन उनकी डायमेंशन हो, ऐसे कांस्टेंट जिनकी डायमेंशंस हो लेकिन उनके मैग्नीट्यूड कांस्टेंट हो. So the physical quantities which have the dimensions but are constant in magnitude are called the dimensional constant. For example, the speed of light. The speed of light is equal to 3 cross 10 to the power 8 meters per second. So there is a unit for a speed of light. It means if there is a unit, then it must have dimensions. Similarly, for the Planck's constant and the gravitational constant, and there are many other examples which are the dimensional constant. Next term is the dimensionless variables. Dimensionless means ऐसी physical quantities जिनकी dimensions नहीं है, जिनके units नहीं है, लेकिन उनका magnitude जो है वो change होता रहे, वो constant ना हो. So the physical quantities which have no dimensions but changing magnitude are called dimensionless variables. जैसे कि हमने इसी चैप्टर में स्टडी किया था, supplementary units, geometrical angles जो थे, plane angle, solid angle, strain. Strain is actually the ratio of the two lengths. So जब same quantity की ratio ली जाती है तो उसके units जो है वो cancel out हो जाते हैं. So इन terms के जो magnitude होते हैं वो different होते हैं, angle change कर सकता है, लेकिन क्योंकि इनके कोई units नहीं होते तो इनकी कोई dimensions भी नहीं होती. तो ऐसे variables जो हैं वो dimensionless variables कहलाते हैं. Last term जो है that is dimensionless constant. The physical quantities which have no dimensions but having the constant magnitude are called the dimensionless constant. ऐसे constant जिनकी value भी change ना करे, उनके magnitude constant रहें और उनकी कोई units भी नहीं हो. और इनकी examples हमारे पास क्या हैं? Pure numbers 1, 2, 3, -1, -2. So all these numbers, the pure numbers, are the constant and they have no dimension, and such as the number pi, whose value is equal to 3.14 and so on. So these constants which has no dimensions are called the dimensionless constant. Four terms हमने स्टडी की हैं: dimensionless, dimensional variables, dimensional constants, dimensionless variables, and dimensionless constants. Now we will see what is the dimensional formula. So the expression which shows how and which of the base quantities represent the dimensions of a physical quantity is called the dimensional formula. ऐसी expression जो कि इस चीज को show करे कि हमें किस तरह से base quantities को जो है represent करना है in the form of the dimensions of a physical quantity, that expression is basically known as the dimensional formula. So for example, for the volume, its dimensional formula is m0 L3 T to the power 0, because volume is just the length multiplied by width and multiplied by height. Its unit is meter cube, so it only depends on the length. It does not depend on the mass or on the time. So the dimensions of mass and time will become 0, their power becomes 0, and L to the power 3 will be the dimension for the volume. Similarly, for the speed or the velocity, it depends on the length per unit time. So mass term will be 0, its power will be 0, while L to the power 1 and T to the power minus 1 will be the dimensional formula for the velocity. And the dimensional equation is an equation which is obtained by equating a physical quantity with its dimensional formula is called the dimensional equation of the physical quantity. So the dimensional equations are the equations which represent the dimensions of a physical quantity in terms of the base quantity. For example, the dimensional equation for the volume will be equals to V in the bracket will be equals to the dimensional formula of the volume. And for the speed or the velocity, it will be the small v in bracket equals to m0 L t minus 1 and so on for the other dimensional equation. And the dimensional equations can be obtained from the equation representing the relation between the physical quantities. So now let's move on towards the advantages of the dimensional analysis. By using the methods of the dimensions, which is called the dimensional analysis, we can check the correctness of the equation and also we can derive the formula. So the one of the advantage is we can check the correctness of a physical quantity. So in order to show the rightness of the physical equation, we have to show that the dimensions on the both sides of the equation are same without any regard to the form of the formula. Whatever the formula is, the dimension on the two sides has to be equal. And this is called the principle of dimensional homogeneity of a physical equation. But the limitation is, even if a physical relation is dimensionally correct, it does not prove that the relation is physically correct. ऐसा नहीं है कि अगर कोई इक्वेशन डायमेंशनली प्रूव हो भी जाती है कि उसकी डायमेंशंस दोनों साइड पे इक्वल हैं, हो सकता है वो इक्वेशन फिजिकली एग्जिस्ट ही ना करती हो, उसका रिलेशन किसी भी फिजिकल नेचर के साथ रिलेट ही ना करता हो. सो ये एक इसकी लिमिटेशन है जिसकी वजह से हर इक्वेशन जो डायमेंशनली इक्वल हो रही है उसको हम फिजिकल इक्वेशन कंसिडर नहीं कर सकते. Second advantage of the dimensional analysis is deriving a possible formula. With the help of the dimensional analysis, we can derive a possible formula, but the success of this method depends upon the correct guessing of various factors on which the physical quantity depends. And the limitation of this advantage is that dimensional analysis is very useful in deducing the relations among the physical quantities, but the dimensionless constant cannot be obtained by this method because the dimensionless constant does not have any dimension. So we cannot be able to obtain those constants with the help of the dimensional analysis. And also, the method of dimensions can only test the dimensional validity but not the exact relationship between the physical quantities in any equation. And it does not distinguish between the physical quantities having the same dimensions. Just like the radius, the diameter, the chord, the circumference of the circle, the distance, the displacement, all of them have the same dimensions. So it cannot distinguish between the physical quantities having the same dimensions. So ये हमारे पास dimensional analysis के advantages होंगे और इसी के साथ साथ limitations जिससे मजीद हम इन dimensional analysis को utilize नहीं कर सकते. Dear students, now let us solve the two examples 1.6 and 1.7 related to the topic. Example 1.6 is using the dimension analysis to find the correct relation. Either option A, f is equals to mv square over r square is correct, or the option B, f is equals to mv square over r is correct. So we have to use the dimensional analysis to find the correct relation for the drag force. So dear students, let us solve this example by using the dimensional analysis. For this, first we have to write down the dimensions of the given physical quantities. First quantity which is given is the force, and the dimensions that are used for the force are m, l, t minus 2, as the force is equal to mass times acceleration. So the m is the dimension for mass, and for acceleration the dimension is lt minus 2 meters per second square. The dimension for the mass is m. The dimension for the velocity is lt minus 1 meter per second, and the dimension for the radius is the length. And to check either the given relation is correct or not, we have to equate the dimensions of the two sides of the equation. So solving for the first part, which is for the option A, the equation is f is equal to mv square by r square. The dimensions on the left hand side are the dimensions of the force, which is mlt minus 2. And if we solve this equation for the right hand side, then we get m for the mass, lt minus 1 for the velocity, and the square from the formula divided by the dimension of length for the radius, and again square of the formula. While simplifying this, the equation for the dimension becomes m l square t minus 2 divided by l square. The square term of the length is get cancelled, and we are left with m t minus 2. Hence, the right hand side is not equal to the left hand side of the equation. Then we can say that the first equation is not dimensionally correct. Now, dear students, let us see either the second equation, the second relation is correct or not. So for this, again, the dimension on the left hand side is the dimension of the force, which is mlt minus 2. And on the right hand side, there are the dimensions of the mass, which is m, the dimension of the velocity, which is lt minus 1, and square from the formula, while the dimension for the radius is the dimension of the length. And if we simplify this question, then we get m l square t minus 2 and divided by l. One of the dimension of the length will get cancelled, and the right hand side will become m l t minus 2. And now the right hand side of the equation is equal to the left hand side of the equation, due to which we can say that the second formula, which is f is equals to mv square over r, is dimensionally the correct relation for the drag force. Now the example 1.7. When a solid sphere moves through a liquid, the liquid opposes the motion with a force F. The magnitude of force depends on the coefficient of viscosity, having the dimensions of the mass, length, and time of the liquid, the radius r of the sphere, and the speed v of the sphere. Assuming that force is proportional to different powers of the quantities, guess a formula for force using the method of dimension. Now, for this question, we have to again use a dimensional analysis to find out the formula for the drag force. Now, the given things are the drag force is proportional to the sum power of the coefficient of viscosity. It is proportional to the sum power of the radius of the sphere. It is proportional to the sum power of the speed of the sphere. Since we do not know either the relation is direct or indirect, either these powers are positive or negative, or either these powers are 1 or greater than 1, so we have given the name to the powers as A, B, and C, and we have to find out these powers by using the dimensional analysis. And now if we remove the proportionality sign, we get a constant, and in this case, let's consider the constant as the K. You can write down any alphabet as the constant. And then viscosity to the power A, radius to the power B, and velocity to the power C. Now we have to substitute the appropriate dimensions in this equation. The dimension of the force is mLe minus 2 kilogram meter per second square, and this will be equal to the constant values does not have any dimension, so there will be no dimension for the constant K. The dimension for the viscosity is given in the question, which is mL minus 1 T minus 1 to the power A. The radius is has the dimension of length L to the power B, and velocity has the dimension of LT minus 1 to the power C. Now compare the powers, and before comparing we will write down the similar terms together, just like n to the power A, L to the power minus A plus B plus C, and T to the power minus A minus C. And now we will compare the powers on the two sides for the similar physical quantity. First of all, for M, the dimension on the left hand side has the power 1, while on the right hand side the power for M is A, which means A is equal to 1. And if we compare for the time, then on the left hand side T has the power minus 2, while on the right hand side the T has the power minus A minus C, from which minus 2 is equal to minus A minus C. And if we substitute the value of A, which is 1, so we can solve this question for C, which is equal to 1. And for the length, L is equal to 1 on the left hand side, and on the right hand side L is equal to minus A plus B and plus C, which means 1 is equals to minus A plus B and plus C. Now we will solve this for B, and by substituting the value of A and C, we can solve this equation for B, and we get B is equal to 1. Now, dear students, let us substitute these power back into the equation, which is the drag force is equal to K viscosity to the power A radius to the power b, and velocity to the power c. And a, b, c, all of these powers are equal to 1. So it means the formula will be F is equal to k, viscosity, the radius of the sphere, and the velocity of the sphere, or the speed of the sphere. So this will be the formula for the drag force. Now, the limitation of this method is we cannot able to find out the value of this constant k. But experimentally, we can calculate the value of the constant, and it is calculated, which equals to 6 pi. So the actual formula for the drag force is F is equal to 6 pi eta r b. And we can only find out the values of the constant by the experiment. With the help of the dimensional analysis, we cannot be able to find out the values of the constant. Dear students, your homework for today is assignment number 1.6 and 1.7 from your book. Question number 1.6 is show that the equations Vf is equals to Vi plus At and S is equals to Vit plus half At square are dimensionally correct. And question number 1.7 is find an expression for the time period of a simple pendulum. The time period may depend upon mass of the bob of the pendulum, length of the pendulum, and acceleration due to gravity at the place where the pendulum is suspended. This is the end of the lecture. I hope all of you have enjoyed today's lecture. Thank you so much. For any kind of queries, you can write your question in the comment section. See you in the next lecture with the new topic. Till then, take care and Allah Hafiz.